And question number 4 is nice because parts of it review some of the things. Oh, I'm moving. Thank you. Sorry, there we go. Parts of it review some of the things that we've done already. Now, what we're moving towards and what we're going to get to today is what does it look like to graph a sine graph and a cosine graph when you have all 4 major transformations. Vertical and horizontal stretch compressions, vertical and horizontal translations. What we've done so far is we've done each of them separately. We talked about what it meant in transformations, but also noticed a shortcut for graphing sine and cosine. The first one was our a value. So we can do that for part A. Y equals 3 sine x. And it says for 0 less than x less than 2 pi, we're going to say for at least 1 period. So this 3, right, we know that this is a vertical stretch. You multiply your y values by 3, but as part of the shortcut that we noticed in the example before, that 3 affects your amplitude. And the amplitude of a sine graph is the distance from the center line to a maximum and the center line to a minimum. So for this graph, we can actually go and graph it fairly quickly. We know that because of that 3, our maximum will go up to 3, and our minimum down to -3. The period of a regular sine graph is 2 pi. We always mark our period and put it in 4 equal sections. So this is just our axes family. And you're going to hear me talk a lot about where does a graph start. For a sine graph always starts on a center line going up. A cosine graph always starts at a maximum. So here we have a sine graph. I go to my center line, and I need to go starting up. So at the next sticky mark, I'll be right at my maximum. Then I'll be back to the center line, then to the minimum, and then back to the center. Put arrowheads on this. We've graphed at least 1 period. And so the value of 3 out in front, that affected our amplitude. The next thing that we looked at was if there's a value inside where I have the b value. Oh, by the way, somehow you will have to come up with a very strategic way to remember that a goes with amplitude. I don't know how you're going to remember that the a value goes with amplitude. Some sort of strategic way, however you can come up with that, each on your own, right? We have to remember that a goes with amplitude. Now, our b value. We learned that our b value, so here we have y equals sine 3x. In transformations, we would have learned this was a horizontal compression that you would multiply all of your x values by 1/3. Our shortcut that we noticed when we did the b value before is that our b value is going to affect our period. Because if our period was from 0 to 2 pi, and now you've compressed it by 1/3, your new period is going to change. And we learned that there was a formula for sine and cosine that your period is always 2 pi over b. So in our situation, since our b value is 3, our period is going to be 2 pi over 3. So I used the formula to figure that out. Maybe you can see it with the horizontal compression as well. If your period was 2 pi and you multiplied by 1/3, does it make sense that your new period would become 2 pi over 3? So The formula is there, but the formula is just an explanation of the horizontal compression. So when we go to graph this one, our amplitude is 1, so it'll go up to 1 and down to -1. And on our x-axis, we're going to mark our new period, which is 2 pi over 3, and divide it into 4 equal sections. And here's where we need to do a little bit of mental math for labeling. If this is 2 pi over 3, I find that the middle one is the easiest one to label next. The middle one will be half of this one. If I take 2 pi over 3 and I multiply by half, can you see that you would get pi over 3? Then the next of those 4 ticking marks, the next one that I would mark would be the first one. Because the first one is going to be half of the pi over 3. So if I take pi over 3 and multiply it by half, I will get pi over 6. And then the last one is the third one. And since we know that one of them is 1 pi over 6, we can just use counting to say, well, if this is 1 pi over 6, this will be 2 pi over 6, this will be 3 pi over 6. And you could reduce that if you wanted to pi over 2, or you could leave it as 3 pi over 6. Both would be fine. So our b value helps us figure out our period. Our period helps us label our x-axis into 4 sections. We always start by labeling our period, dividing it into 4 equal sections, and now, since this is a sine graph starts in the middle going up, here's my middle, going up to a maximum, back to the middle, down to a minimum, back to the middle. And here is our graph. There isn't a review question on this one for your C value, but remember C value there, that's a horizontal translation that takes a graph and moves it left and right. So we could do that. I don't know if you remember when we did the C value question, we first drew the graph without the shift with a dotted line, and then we shifted all 5 points either left or right to see where it's going to go. But the one thing we haven't done a graph for yet is what happens when there's a value where the letter D is. That would be a vertical translation, either up or down. So for C, we have y equals sine x plus 3. This 3 is going to be a vertical translation up 3 units. So I'm going to start, just because we haven't graphed it yet, always have in your mind your regular sine graph. Your regular sine graph has a max of 1, a min of -1, a period of 2 pi split into 4 equal sections, which is just your axes family. Sine graph starts in the middle going up. So just for a visual, there's our sine graph. And what we need to do is we need to shift this up 3 units. It's not very hard to do. But something that hasn't come up is on a sine graph, we are actually going to label the center line with a dotted line. So the center line up till now has always been on your x-axis, and we've kind of used the x-axis as a label for a center line. But in all of our graphs where the center line is different, we're going to take out a red pen and draw a dotted line. Not an asymptote, but it's like an asymptote. Technically, when you draw a dotted line on a graph, you are saying that this dotted line is not part of my graph, but it's helping me draw my graph. So the center line is going to help us draw the graph because sine graph goes from center line to max, to center line to minimum, to center line. So having that drawn is going to be helpful. Our amplitude is 1, and our amplitude is what the distance from our center line to a max and a min would be. So one of the things that our center line helps us with is it helps us label, and we're going to label our maximum. We go up 1 to 4, and our minimum, and go down 1 to 2. Our period is still 2 pi. So we take 2 pi, divide it into 4 equal sections. Here's our axis family. And all we're doing is taking that regular sine graph and moving it up 4. But if we've labeled our center line and our max and our min and our period in 4 sections, then drawing the 5 points is really easy because a sine graph starts in the middle, going up. So we have our middle point, then at the next ticky mark we go up to our maximum. Next ticky mark, back to the center line. Next one, down to a minimum, and finally, back to the center line. And this is our final graph. So you can circle questions 6 and 7.